This matrix gives us a summary of the different DOE types, or at least the different test methods for root cause analysis. So the first one noted here is trial and error, then shotgun, one factor at a time, otherwise known as OFAT, classical DOE, Taguchi DOE, and then Shannon DOE. And as you can see in the matrix, it's intended to give you some sense as to what the cost is like, whether or not you can find main effects or interactions, whether or not the technique permits you to look for optimization and or develop a prediction equation of some kind, and then whether or not it would lead to fixing the problem for the last time. So although I won't read all of these, you can kind of see that at one end of the spectrum is trial and error, very high cost. It's not likely to find main effects. Certainly wouldn't find interactions unless you're very, very lucky to have discovered either of those. It doesn't allow for optimization, and it probably won't fix the problem for the last time. So really, although you do find it commonly used, it doesn't have a lot of redeeming value in terms of an investigative tool or root cause analysis tool. Next we have shotgun. So this shotgun is where we're changing a lot of things at once, and so while the cost may be a little bit lower, still there's really no opportunity for the process improvement professional or the belt to really discover what it is it's telling us. OFAT, or one factor at a time, tends to be the logical tool of use when no training has been given in design of experiments methods. So we identify the factors that could be contributing to the root cause, and we change one factor at a time and see how the system responds or the output responds. And again, while this is maybe medium, it is possible to find a root cause, but then there's no further opportunity to take that and optimize it in any way. And then you've got sort of the three types of different DOE. You've got classical DOE, then you've got a Taguchi DOE, and the difference here is Taguchi is not generally used to find interactions. And the last one is Shannon DOE, which is not commonly seen in DOE type material, but Dorian Shannon, he characterized and called the methodology that he uses, design of experiments. Although when we get into it later in the training, you'll see that Shannon is, although it is a discovery type of a set of tools, it really isn't a design of experiments as you might typically have understood or were previously trained. Now, I just want to look briefly then at each of the classical Taguchi or Shannon DOE. So these three methods comprise what I would call true design of experiment type methods. So the primary tools are factorial experiments, orthogonal arrays, although classical does have orthogonal arrays as well. So you've got orthogonal arrays, and then over on the Shannon side of the house, the tools are just a somewhat eclectic but nonetheless effective collection of different tools and techniques, and you can see them here. The advantages are that classical really does handle the interactions very well. Taguchi is quite quick. In Shannon, one of the assumptions is that interactions don't affect the process, although there is some accommodation for seeking out interactions. The cost and time is, it can be, like a classical DOE can be quite costly and time consuming because you generally have to have the operation shut down and or have the ability to accommodate the different designs that are in the or the different runs that are in the design itself. On the other end of the spectrum, you have Shannon, which has little to no interruption in the production. Training, it can be high for classical DOE. On the Shannon end, it's quite low and quite easy to adapt to sort of shop floor level experience and expertise. The scope, in terms of software, classical really does require some sort of software, although of course you can do all of this by hand, but it's quite laborious. So needing software, and as does Taguchi, but Shannon generally doesn't require any kind of software. And then the ease of implementation is moderate in both cases here in classical and Taguchi. And then in the Shannon side, it says high, so meaning it's quite easy to implement. The tools and techniques are quite easy to understand. So that's an overview of the different design of experiment types.